Okay, we are ready for Algebra 2 here, Chapter 8. We are going to start a new chapter here after our test last time we were together. So pretty much what this will look like, there will be a good amount of lessons over the next couple of weeks. Really just one quiz here over the first stretch of 2 weeks. But pretty much you'll watch the video lesson here that's recorded, take notes, follow along on the whiteboard. And then, of course, the homework assignments are listed on RunWeb and Google Classroom. And for the most part, you'll complete those on paper, take a picture of those, submit it, upload it to Google Classroom, and I'll grade it from there. And of course, any questions as we go along. And then the quiz, we're still working through what that'll look like, but that's not till next week. Anyways, this whole first week, we'll just be doing lessons in Chapter 8. As we talk about the topic of exponential and logarithmic functions. So fun. What is that? What is that topic talking about? Well, obviously exponential. Last chapter we did a lot with exponents, and simplifying root radical form. Okay, so we kind of then continue on this chapter into exponential equations, which still says, all right, how do you solve for x? How do you solve for an equation? But the exponents within the equation either aren't the same, or even sometimes the x is an exponent. The variable is an exponent. How do you solve those? And then logarithmic, if you look back on page 472 or so, is the start of the chapter. Logarithm, that is the log button on your calculator, the log and the ln button. And so we'll talk this chapter what that means and how to work with that. So as we start 8.1, it is split up into 2 parts. So 8.1a, graphing exponential functions. I'm going to try to type a good amount on the whiteboard so you can read it. And then, of course, we'll, with the pen and on the whiteboard here, do some problems together. So 8.1a, get that title down there. And then point number 1, and just 1 today, and yeah, we'll look at the rest of section 1, I should say, in the next lesson. But graphing growth functions. So this is number 1 here within our notes. Couple definitions. So first of all, what is a growth function? And then secondly, what does it look like to graph that growth function? So our first definition is, first of all, what is an exponential function? So what makes a equation or a function exponential in nature? Okay, so our first definition here in red. An ascension exponential function, I'm going to try to use an equation here so that's a little easier to read. Y equals b to the x power. Okay, so essentially, this is our exponential function equation. So you have y, or f of x, it's a function. But y equals b to the x power. So notice there, the tricky part here is that the exponent is sometimes unknown, okay? With these exponential functions. So the exponent is something that we're going to solve for. And up until now, we've only ever had numbers as the exponent, but now we'll include some variables as well. So that is the exponential function where b is greater than 1 or 0 is less than b, less than 1. And the exponent is a variable. Okay, and there's 2 types of exponential functions. There is the growth function, and then there is what's called a decay function. So that's the last part of our definition here. The 2 types are growth and decay. All right, so those would be the 2 types of exponential functions. So this first one, you see in point number 1, it says graphing growth functions. Now, what is this kind of type of equation here, exponential functions? Well, it's very applicable. The reason we're not having school for this lesson here currently is because we have an epidemic of coronavirus that is spreading wildly. Part of the problem, part of the reason we don't have school is because the virus is spreading very rapidly. You could say exponentially. Okay, so we've heard this before. Sometimes it just takes a minute to connect to our real life brain. But exponentially, right? Let's say you over this 2-week break, I've encouraged some of our athletes, specifically male athletes, to spend time not only academically learning, but also physically getting stronger and working out and using your time wisely rather than just sitting on the couch. But spend some time working out, bulking up over these couple of weeks. Well, you hope as you gain muscle, okay, if you gained muscle day after day, okay, just kind of in summation, right? You're building on the previous day. That's good, but exponentially, okay, think about it number-wise. Let's say you gain exponentially, okay, you gain 2 pounds of muscle, and you do that exponentially. Well, now all of a sudden, rather than 2 plus 2 plus 2, it's 2 squared, 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 exponential, right? And all of a sudden, it's growing much faster. The virus, okay, growing exponential. In other words, 10 people had it, and then it's growing exponentially by a rate of 2. Well, then 10 squared, 100 people, and then squared, 100 times 100, okay? 4 zeros after that. What is that, 10,000? So exponentially essentially means something's going to grow very quickly. And so with a graph, obviously it's going to be a type of curve that starts and then it grows very rapidly. That would be growth. Decay is similar, but the opposite, where it's something that is up high or where it started, and then it's decaying. It's going down rapidly. Okay, it's going decaying, going backwards. This is a pretty in-depth lesson, so we're just going to do growth. We're going to kind of skip over for now decay, but again, it's a great kind of illustration and connection to money, business, okay, stock market, all these things. You want something that grows exponentially, and you want to be very careful about things that decreases or decays exponentially. So one more, that's our kind of our first definition. I guess I should put this over and make this bigger. But essentially, that's our first definition, exponential function. Our only other definition here, make that a little bigger, is then we're going to kind of explore this exponential growth function. So one more definition there in red, and that is the exponential growth function. So what are some particulars? That's with exponential functions, but then specifically with exponential growth functions. Well, first one is that it is going to graph a curve that increases from left to right. Okay, so it graphs a curve, graphs a curve that increases from left to right. Also, it crosses the the y-axis at 0, 1 and never touches the x-axis, which acts as the asymptote. Okay, and if we were going to do an example there, it'd be y equals 3 to the x power. Okay, so an exponential growth function essentially graphs a curve that increases from left to right. Okay, as when we look at some, you see them in the book. If you have your book there, page 405, I will encourage you. Obviously, you're gonna have to have your book for homework and things, but do follow along. It's, we don't typically a lot in class. It's a little easier to interact, but especially here online, it's good to have the book open and kind of go through some of these examples. Also, sometimes I may not even put all the examples here on the board just because it's a little more difficult, and I'll just reference them in the book. And then we'll do some on the board here as well, but good to look at the book. But you see there, if you're looking at page 475, an exponential growth function essentially starts over infinity on the negative x-axis, and then it grows very quickly, okay? And then a basic equation here would be y equals 3 to the x power. Some particulars you want to know. What's always true about these, until we get to transformations tomorrow, but what's always true about these regular graphs is it crosses the y-axis at 0, 1. Never touches the x-axis, which acts as an asymptote. Remember, asymptotes are simply equations or values that would make the function undefined or would make it not possible. So there are asymptotes here that would make the function or the equation undefined. Okay, so let's get some, I can scroll down here. All right, we'll do another board. We'll just kind of go back and forth. So hopefully you have those definitions down. There, that kind of explains and gets us started with exponential functions. All right, really just two quick problems today. The bulk of our time was spent kind of explaining what these are, and then tomorrow we'll look at transformations. But essentially, you see there in the book, if you're on page 475, that the basic curve that I just graphed, or that I just gave you, y equals 3 to the x power, if we plotted a table, okay, it would essentially look something like this. I'll do this one on this board here, where essentially, okay, if you had your axis, your xy axis, ooh, that was rough. All right, essentially at 0, 1 for y is going to be where it crosses the y-axis. Okay, so that's your main point. If I was going to do a quick freehand of this, it's never going to touch the x-axis. It's going to cross there, and then it's going to grow exponentially. Okay, and it's going to be a smooth curve, as smooth as I can get it there on our screen. But essentially, it's a smooth curve. Let me try one more time. So we're going to draw straight lines. There it is. Look at that. Straight line. It's a straight line tool. It's beautiful. All right, so 0, 1. Here we go. See, look, we're learning already. It's going to be very close and then grow. And I missed my point. What do you do when you miss your point as a math teacher? You make the point bigger. Here it goes. So it crosses at 0, 1, grows exponentially. Okay, so again, that would be something like y equals 2 to the x power or 3 to the x power. Really, it doesn't change a whole lot. Okay, with this number. This number only affects it a little bit. Those graphs look very similar, whether that's a 2, 3, 5. Starts getting really big, it'll change obviously a little bit. Okay, and to start here, we'll essentially just make a table. So let's go ahead and let me do a new board here. And let's try a couple problems. And of course, you can do these in blue if you could. And so essentially here, we're going to have our graph. And then we're going to have our equation, which is y equals 4 to the x power. Okay, let's do a table here. And again, I'll just kind of show you where these points come from. It'll make a little more sense. So if this is my basic equation, okay, if I was going to do a table, I'd do x comma y. Okay, and I'd test points for x and then figure out what they were for y. So if I tested a 0 for x, well, look up here, 4 to the 0 power equals 1. So that's where my main point comes from. And that's why you see all of these graphs are going essentially to cross at 0, 1. Because if you put a 0 in for x, no matter what this number is, right, anything to the 0 power is going to equal 1. All right, if I kept going, if I tested a -1 for x, well, if I went up to the side here, 4 to the -1, remember, means we flip the whole fraction to make the exponents positive. So 4 to the -1 gives me 1/4. And this is why on the left side, we say at -1, it's going to get very close to the x-axis, but never touch. The farther you go down here, the more it's just going to get closer and closer, but never touch that x-axis. Okay? If I went the positive direction a little bit, I would have a 1 there. If I plug in a 1, 4 to the first equals 4. Notice how rapidly that grew. At +1, we're already all the way up here. 1, 2, 3, 4 at +4. All right, and then we can do one more point, and that is a +2. 4 squared, boom, and see how fast we grew there. At +2, we're all the way up here at +16. Okay, so again, really what happens is the larger that this number is right here, the larger that number is, the faster it's going to grow. If it's a 2, think about it, it's going to be 2 squared is 4. So the bigger that number is, the quicker it's going to grow. Okay, pretty much we just make a table for that. If we're going to do domain and range, all right, real quickly here, domain, of course, would be all real numbers because any number for x is going to work. The range for these is simply any number for y greater than 0. Okay, so that would be my domain and range. All right, we're about to get knocked off. We have about 15 minutes on this video software that I'm using. Tomorrow we'll look a little bit more at transformations. Okay. For now, just kind of be familiar with what these exponential growth functions are, and then pretty much just for now make a table and use that table to graph and plot your points. And then tomorrow we'll look a little bit deeper, once we get those definitions out of the way, at exactly what these graphs look like, okay, as we go forward. All right, that is section 8.1a. Thank you.